Hello, greetings to Dr. Razak. My group will be presenting our final project for course KMK 1143, which is Artificial Intelligence. So our group consists of 5 members, including myself, which is I am Noor Farzana. So the others are Noor, Farah A, Noor, Iryani, Athirah, Prawin, and Ravindravel A. To start off this presentation, I will do the introduction part. So, what is artificial intelligence, or known as AI? So, AI is a way to make machines think and behave intelligently, which is based on artificial intelligence with Python by Pratik Joshi. And next, it is a sign where it consumes theories in the input system where the output will help people who need guidance, which said by Joshi 2017. To start off this presentation, I will do the introduction part. So, what is artificial intelligence, or known as AI? So, AI is a way to make machines think and behave intelligently, which is based on artificial intelligence with Python by Pratik Joshi. And next, it is a sign where it consumes theories in the input system where the output will help people who need guidance, which said by Joshi 2017. Next, our group has decided to choose music recommendation system. Music recommendation system that we made by based on Python coding that we've learned throughout this semester. We have decided to name it as HarmonicHaven, personalized music creation through advanced AI. This project system has an extensive scope which includes user behavior, audio features, contextual information, and social connections.
Hi guys, I'm Ravin. Today I'll be presenting the motivation behind our AI-based music recommendation system project. The music streaming industry has been completely changed the way people listen to music. With so many platforms and millions of songs available, it can be difficult for users to find music that they actually enjoy. That's where our project comes in. We are building an AI-powered recommendation system that helps users discover music based on their personal taste and listening habits. By analyzing data like favorite genres, past behavior, and listening patterns, our system can suggest songs users are more likely to enjoy. We are also addressing common AI challenges like the cold start problem, where users have no history and data sparsity when used data is limited. Lastly, we choose this project because it gives us the chance to apply what we've learned in class, from preparing data to building algorithms, and see how theory connect to real world impact. That's all. Thank you.
Next, we are going to talk about related work based on music recommendation system. My name is Pravin, and I am doing the related work based on music recommendation system. I've been searched for 10 research, and the first one is Deljo's context-based rec system survey, which is review audio, lyric, and metadata-based recommendation method, addresses the challenges in explainability, fairness, and cross-domain recommendation. Next, Dan Heeson's and Bauer's research paper, which is fairness review, highlight gender and popularity bias in music recommendation system. And we are moving on the third, which is Chen's research paper, which is multi-objective rec system, which is balance precision, novelty, and diversity in recommendation. Next, we are moving on to Zhang's research paper, which is genre classification model, which is combined ResNest and BGRU on male spectrogram for music genre classification, which offer insights for cold start recommendation and based on analysis. Next, we are moving on emotion plus collaborative filtering model. Two submodel system combining real-time emotion detection with collaborative filtering. After that, the sixth research paper is Moose by O et al. Self-supervised contractive learning model for shuffle mood music recommendation. It will outperform 12 baseline on real-world data by modeling shuffled session and improving song transition. Next, PISA by Tran. It will transformer model using ACT-R cognitive principle like repetition and memory decay. Moving on to GSRNN by Reddy, an hybrid RNN model fine-tuned with gravitational search algorithm GSA for enhanced content-based recommendation. Moving on to T-Rexis by SAW, an hybrid deep learning model combine collaborative and content-based by filter for better personality and outperform baseline on Spotify data and mitigate cold start issue. Finally, by Babu, emotion-aware recommender, which uses facial expression analysis to match user emotions with music genre in real time, improve emotional satisfaction and engagement.
Assalamualaikum, my name is Noor Iryani Athirah, and for my part, I will be explaining about implementations. Project is called Music Recommendation System, HarmonicHaven. It's designed to personalize users' experience by recommending songs based on their favorite genre, which consists three genres: pop, rock, and R&B. The goal is to increase engagement and help users to discover new music with more detailed and personalized suggestions. The system is very simple desktop application which is built with Python using Tkinter GUI library and uses a local CSV file which is song CSV as the music database. We also use the Pandas library to handle data efficiently by reading and processing the song CSV file into a data frame. The recommendation logic is simple. It filters songs based on the user's chosen genre and returns to the top matching tracks. To improve user experience, we also added user-friendly error message using Tkinter message box, which notifies users about issues like missing file and incorrect CSV columns name. The song CSV file is a comma-separated value file that acts as the database for our music recognition system. It contains all songs data used to generate recommendations, with each row representing one song and its key attributes. This part I will be explaining about implemented features. First, we have CSV data loading, which is the system very successfully loads songs data from a song CSV file and expecting genre, title, and artist columns. It includes initial error handling like file not found error and missing required columns. Second is dynamic genre extractions, which once the CSV file is successfully loaded, the application automatically extract and sort unique genres from the other genre columns to populate the drop-down menu. If no genre are found, a default list of genre is used as a fallback. The recommend by genre functions then filter the database based on the selected genre and return to the top 5 matching songs. The third one is multi-page GUIV navigations, which is about implemented using TK frame object. The application seamlessly transitions between a home page, general selections page, and recommendation display page by packing and unpacking frame. Fourth is interactive user interface, which is provide a clear TTK option menu for a general selections informative level and distinct TK buttons, widgets for navigations and triggering recommendations. For the last one is recommendation display, which is the system will recommended songs with titles and their artists are presented in a scrollable TK text widget on the output page with a clear headings and formatting.
Next, the unimplemented features. First, the system doesn't support user accounts, so it cannot remember your preferences or listening history. Second, there's also no search function, which you cannot look up specific songs or artists, and you can only browse by genre. And the third one, the recommendations are quite basic since the system doesn't learn from what users like or listen to, as it doesn't use advanced recommendation algorithms or learn from user behavior. For 4.3 evaluation of software performance and accuracy. Our system performs really well when it comes to speed. It loads data, files in just milliseconds using pandas, even with large files. The recommendation process is also super quick as it simply filters songs by genre and displays them instantly. Not only that, the interface is built using Tkinter and is very responsive, meaning drop-downs and button clicks work smoothly without delay. For the software accuracy, in terms of accuracy, the system does exactly what it's supposed to, as it correctly shows the first 5 songs that match the selected genre. However, since it's a basic rule-based system, it doesn't use machine learning or smart algorithms. So we don't use standard accuracy metrics like precision or recall because the system doesn't track or learn from user behavior. Now, this is our input, which is the first picture, the second picture, and the third picture. And this is our Python code, full Python code.
Finally, working on this project as a group has been a valuable learning experience. We combine our skills to successfully develop a basic yet functional music recommendation system. Throughout the process, we learn how to manage data using pandas, build a user-friendly interface with Tkinter, and implement a simple but effective genre-based recommendation logic. Collaborating as a team allows us to solve problems more efficiently, share knowledge, and divide tasks according to our strengths. This project not only enhance our technical abilities but also improve our teamwork and communication skills, which are essential for future collaborative work. Thank you.